Yeah, so I'm going to talk about a little bit about what we're trying to do and why, and then the bit people actually want, which is graphs of models doing stuff. So, okay, briefly, we would like an evaluation that where when the number goes up, that corresponds to the models being more dangerous and scary. We would also like, not only are these things correlated, but we can say, like, for a particular absolute value, like, this is how scary this is when you need mitigations. And there's a bunch of different properties we require of the tasks and activities the models are doing as part of this evaluation in order to get these properties, including that they're not sort of Tory game environments, and that there's some meaningful way to interpret the score, and that they cover a wide range of things, and it's not just going to be like, oh, it happened that the models were really good at this one narrow thing, so now we say we have to implement these expensive mitigations, but actually they're not concerning. We would also like I keep saying this as the y-axis ticks to be evenly spaced, but apparently this only makes sense to me. So basically we want to be able to forecast, we want it to go up smoothly. We want to be able to say here's how much this jump was, and there's this many more jumps until we hit the threshold, or something like that. Yeah, so we would be able to say, with these current models that we have, some amount of elicitation effort produces this much improvement in performance. Therefore, when we're setting a threshold, we need to allow this much buffer for the possibility of more elicitation if the model is stolen or something like that. And this is the obligatory why is everyone else's things lacking slide. Various things that you might want, having had humans do the tasks in a directly comparable way so that you can then sort of calibrate to how well humans did. But I think a lot of how we're thinking about building this is importing a bunch of other people's tasks and doing the human baselines and scaling them and weighting them in various ways and kind of accumulating all of this. Okay, so the actual things we have built are this general suite of tasks distributed across a range of difficulties and different domains. Some examples are sort of different science or math or inference tasks. Some things that test some amount of interaction or adversarial robustness. Some sysadmin things, different scientific computation challenges. And in particular, we've lavished special care on a small number of tasks testing things that are part of frontier AI development workflows. They're selected to be some kind of optimization or prediction problem. You're trying to make a number go up and you can measure how well you're doing. So things like improving the efficiency of something by making a custom kernel, or in order to make it harder to have the model just regurgitate a memorized solution, it's often helpful to add a kind of twist to these tasks so it's sort of structurally similar to the same sort of challenges people need to solve in frontier model development, but it's not something where you can just implement the standard tutorial and do well. So in this case, building a mass language model, but you're not allowed to use division or exponentiation. And then we can normalize these and get some sense of how this compares to human score over time. And we collected a bunch of baselines here. So 44 human expert days on these, so you can kind of see the human sort of trajectory of what score they were getting at what hour and various other things. So actual graphs. This is preliminary results for the new Claude 3.5 Sonnet. I don't know what the, Anthropic, could you please fix your naming schemes? This has really made this graph labeling very confusing. So Claude Sonnet versus Claude, anyway. But we can kind of put in these lines for how does this score compare to like a human given this time limit. And there's various, footnotes and caveats about like ways in which this comparison might be off, but this is the kind of idea of what we want to do, is be able to say like, oh, now models can do tasks that are like a 4-hour, what humans can accomplish in 4 hours. Yeah, you can see number go up. Hopefully number not go up too fast, too suddenly. And okay, so this is just for this AI R&D subset where we can see like the actual trajectory of what score did you get at what time. This is the version of the graph I would show you if I was trying to make you feel as non-scared as possible. So this has Claude 3.5 Sonnet instead of new Claude 3.5 Sonnet, and is showing the some of the better humans. And we see like this pattern of the humans take a while to get started, but they're getting to much higher scores, and it also looks like if you gave them more time, they would keep on going. And the model is more like plateauing and is not able to turn more time and more compute, more GPU time into better performance. Okay, here's the version of the graph I would show if I was trying to scare you. So this is new Claude 3.5 Sonnet, which makes some amount of difference. And then the biggest difference is splitting up the way the agent uses the resources differently. So instead of having like one sort of sequential agent that has 8 hours of GPU time and is just trying to use that, we split it into like 30-minute separate attempts with only 30 minutes of GPU time, and then take the best over that. So this improves performance a lot. It helps more for the new Claude Sonnet than the old Claude Sonnet. Like this is without doing this best of K thing, the results aren't that much different, but it's like it's a bigger difference when you do that selection over best of K. So these, again, the numbers are a little bit various caveats and things, but yeah, it does seem like a general pattern that we're wondering how to think about is like, in what ways is this best of K like fair and representative of real world performance compared to humans, versus this is kind of cheating because most tasks don't have a clear success metric and like aren't sort of sandboxed and easily restartable and resettable. I think, yeah, for tasks that do have all these properties, I expect like post-training improvements over time to basically move this, the no best of K line up to the best of K line, because it seems like you can easily just do expert iteration and get model performance up like that. But the question is like, what fraction of tasks are really like this? So yeah, just showing like even the models are, which are maybe you think they're better at thinking for longer and getting better performance out of that, but they also don't have this plateau. And if you plot this compared to humans, it's very like humans are growing up in a straight line as you give them more time, and like the models are really plateauing. But if you do this like best of K, like wow, that's a straight line, it just keeps going up. I mean, this one isn't with the same fixed amount of GPU time anymore. This is like actually giving it more GPU time and more just a larger number of half-an-hour run attempts. But yeah, you could either be like, it's a straight line that's going up, or like it's plateauing, depending on how much this is something you can do in the real world. Some other miscellaneous things that we've learned recently. Yep, elicitation does still seem important. We get a very big difference with just a small amount of tailoring, scaffolding, and otherwise trying to get the best out of models. This varies a lot based on the underlying model. Like some models are already pretty well elicited and doing reasonable things. Some models like have a strong expectation of some different formatting or are otherwise recalcitrant, and this is helpful. And Finally, it is always, even if you've tested your tasks thoroughly with humans, sometimes models mess them up in ways that humans wouldn't. So it is always important to read your transcripts and see why your tasks succeeded or failed. In this case, the model decided to eliminate the unnecessary step of actually training the model and instead simulate training by modifying the weights slightly, which in fact was a very efficient way of getting a model that matched the performance of the reference model, but it was not what was desired. Yep, I think that is. Oh yeah, we are trying to make as much of our tools and resources and tasks and stuff open source. So if you go to our GitHub or our METR.org, there are various things, and also we're happy to help people, get set up and otherwise collaborate. I think that is everything. Yep.
Could you speak more about your current opinions on how to handle the best of K situation?
I don't know. I feel like I've just been thinking about this over the last few days. But I think the question of cost to reset and expensiveness of failure or mistake is kind of a big part, and the environments where it's in a sandbox, you just restart the run, and having failed at the task doesn't really hurt anything else, is very different from you're trying to kind of have your models automate your whole research organization, and if they mess something up and don't recognize that or sort that out, that messes everything up. So I'm hoping that in the real world, a fairly high level of robustness is required to do a bunch of things. And it does seem, I think this is more obviously true of the sort of rogue agent doing its own thing and gaining resources and being robust to humans case that you have to have a pretty high level of robustness. I think it's less true in a concern about accelerating AI R&D, where maybe you just have the humans build enough of the scaffolding around the models and set up things in such a way that you can get a lot of boost even when models quite often just destroy things.
All right. What evals does METR not have time to do or consider out of scope that you wish other orgs would pick up?
Many. Yeah, so there are various things that other people are doing. Maybe I'll just say what we're not doing, or we are only doing currently these dangerous capability evaluations covering general autonomous agents doing things with a focus on AI R&D in particular. So we're not covering can AI specifically really advance bioweapon design or something, even in just the dangerous capabilities area, and we're not covering persuasion or things like that. Some of this is deliberate choice, we actually think returns on different focus areas are better, and some of it is just we don't happen to have this particular expertise or it's not a good fit. I think control and alignment evaluations also something we would really like to have capacity for and hopefully spinning up soon, but are not currently doing. And yeah, in general, I don't know. I don't think anyone should be oh, METR's got it covered, it's fine. Don't want to, I feel like we've, for some reason in the past, people have gotten the impression that we're more oh, we're keeping an eye on all the labs and we'll tell you if anything's wrong, and we're super on top of everything. In fact, I don't know, we're very talent constrained, and the labs aren't always that compliant, and anyway, we're doing stuff, but no one else should be METR's got it covered, we're fine.
Performance often varies a lot depending on elicitation strategy, as you illustrated with best of K. How can you be confident you're not below threshold only because of weak elicitation?
Yep. Basically, we can't. I think strategies we have here. Yeah, one of them is if we have this nice sort of evenly spaced axis, we can, at least see what differences elicitation makes with earlier models and roughly how much space you should leave for that. I think there's something that's like, there are a class of elicitation problems that are sort of pretty obvious once you look at them. Like if you read the transcript and you're like, oh, the model is just like ethical refusing this for some reason, or like it's trying to use a different formatting, or it's just like submits the task extremely early without checking or something. Like these are pretty obvious and you can just kind of make a fix. And there's other stuff which is like, oh, like either maybe you'd have this one super good idea, or if you did a lot of work and like fine tuning and, you know, lots of iteration on the scaffolding and things, you could get to a higher performance. I think I'm happy to be like, okay, there are some amount of, like, with a large amount of skilled labor or like with a really good idea, you could get a lot better performance. And I'm like, okay, I think we're just, you know, we can't really approximate that. Like that's something we just have to live with. And it is like still somewhat of a barrier if it's like, oh, a terrorist group stole your model, but like it'll be only dangerous if they do like a bunch of fine tuning with good human data or something. You know, that is still a real barrier. And the stuff I really want us to fix as a you know, P0 is like, oh, your score you're measuring is like totally divorced from what the agent's actual capabilities are because of something very dumb, as opposed to like, if you had a research team, you could make this number go up by 30%.
Wish labs did that they aren't currently doing to make your work easier and more robust?
Publish and open source their evaluations and evaluation processes and results, and I guess give us a bunch more access. That would be nice. Yeah, maybe I wish there was a little bit more like standardization on infrastructure and stuff. I don't think this is really anyone's fault, but it just like is a slightly sad situation that there are just a bunch of restrictions here, and like, yeah, it would be good if we could get towards a more interoperable ecosystem.
There is, on your slides, you have this average normalized score, y-axis. Where do you expect models on this to get scary, and what will you do if they reach that threshold?
The AIR&D one, or I guess it doesn't matter that much. I think, I mean, I feel pretty fine about like models that are below what a human can do in a day, and like I assume that they won't have, unless they have some like insanely good narrow capability, that just sort of not being able to like coherently pursue a goal over a day is just going to be a pretty big hit to any threat model. And like I would probably say that extends out to like weeks. I don't know, it seems hard to say. In terms of what we do, like METR in particular does not really have very much power to do things if we see a result. Currently the relationship with labs is very much like, you are under NDA, you get some model access, you do not have any like, you know, authority over you know, warning people if there is a problem or something. But like there are increasingly government agencies that do have that affordance, at least to some extent. So like alerting people who are, you know, who have like legally have the right to know, and being like, we think this is very concerning, and like, I guess I think it would mostly just be like looking into this more and being like, okay, is this model getting this high score for the reason we sort of expected, which is like, wow, really like any task an expert human can do, this model can just like figure out how to do it, and like, you know, it is just like generally capable at that level, and that's how you should understand it, as opposed to like, oh, it happened to be like insanely good at like this set of tasks, even though it obviously has this kind of general limitation of not being sensible in this way. So I think like just doing a lot of more evaluations and figuring out, okay, should we actually be scared yet, would be the main METR activity.
So Quad 3.5.2, or I guess whatever the name is, introduce support for desktop use. So what are your plans for evaluating systems trained for desktop use? Do many things change as a result?
Yeah, I think this is maybe surprisingly unimportant, or like this is my take, is like, basically if a model is handicapped by like not being able to use a GUI, if that is really it's weird for that to be its biggest problem or something. Like a model that's smart enough ought to be able to do like basically everything, from the command line or whatever. And like if there's something where it really specifically needs vision, it can just like download a vision model and like run that and figure the thing out. Like there is, I think if the things that like GUI use unlocks are probably not the like core capabilities that make models scary. I think the main reason that we would end up doing a lot of this is just like, oh, it unlocks a richer range of tasks if you're not trying to avoid things that have sort of dependencies on GUIs, rather than like thinking that makes models much more dangerous if they're not, if they're sort of not able to make progress on stuff just through like code and language.
Who are the automated AI R&D evaluations for? Is the hope that they trigger US government policy, internal lab policies, or something else?
I think any of the above. Generally, I think we're kind of agnostic to whether our evaluations are just being used by, it seems good for people inside labs to have a better understanding of where their models are at. Most people do not, in fact, want to destroy the world. If we give them more information, they will make better decisions. It is also nice for, the EU, the US government, whatever, to be able to be like, here's a concrete line we can draw, or like, here's a number that's a better metric of real danger than like compute thresholds, which everyone hates. So either.
Do you have thoughts on why O1's reasoning isn't helped much, even with larger compute budgets? What does this tell us about inference time scaling laws published by OpenAI?
My guess is that like O1 is not very good at being an agent and doing things that involve like sequential interaction with the environment. Like it seems like it's mostly tries to do things in one step. So it's like good at like doing more reasoning within sort of some bounded length, and then like without having to like get feedback from the environment or like run experiments and sort of get new information and then make a different plan. So my guess is with like more fine tuning on multi-step tasks, it'll have better conversion. But my guess is that like current language models kind of fundamentally have this thing where like, at some point they sort of start going off the rails or being kind of repetitive, or like once they've made a mistake, they're now like conditioned on some slightly confused trajectory where they've made a mistake and a bunch of assumptions and things, and you just like, it requires a fair amount of effort to get the same performance from just one run versus like, sampling a bunch and picking the one that's like going well and conditioning on like, having thus far been successful and sensible.